Today, I'm going to share some of our research and understanding of the issue of population urbanization carbon emission. Over the past 2 decades, there has been a large increase in the studies of demography in population climate change research. Most of the research focuses on adaptation predominantly. I think that makes sense. Particularly when the emission target, the climate target is 1.5 degree, 2 degrees, right? And there is no much you can expect from the demographic system, and it will be largely driven by economic growth and technology changes. But population still can play a very significant role in mitigation. The large climate change research community still needs the input from demographers. And today, I just share some of our understanding and report some progress in the field of population, particularly urbanization and carbon emission. Yesterday, we were here to celebrate Wolfgang's academic achievement. And like many of you, I have been taught, inspired, and benefit a lot from his mentoring and teaching. And the framework I used for the population and environment climate change research is largely based on the population development and environment framework. This inspired by Wolfgang's publication, edited volume in 1994, Population, Environment, and Development and Environment. Under this framework, population is part of the environment. Population demographers define as the size, the structure, compositions, and spatial distributions driven by fertility, mortality, and migration. And population interact with the environment. Environment is defined by the land, water, energy, and air system. Population interact with the environment through its productive and consumptive behavior. Urbanization matters can play an important role in the interaction. Urbanization not only changes the residents of the population, but also changes the work style, the living style, lifestyle, and also the consumption patterns and value system and social interactions change the economic structure, change the social structure, so it matters. If you look at the history of urbanization, the urbanization was kept at a very low level, below 10% globally. And until after the Industrial Revolution, the urbanization level increased exponentially. And to a large extent, it accompanied the changes in economic growth and the carbon dioxide emission and climate change. Of course, there are large variations across regions. And for instance, Western Europe was the region and take off first after the Industrial Revolution. Asia was one of the regions had almost the same urbanization level in early 19th century. But then after that, the industrialized world urbanized very rapidly. Asia kept a very low increase in urbanization. But recently, after the middle of 1950s, the urbanization in Asia also take off. So just as Kingsley Davis said in his paper published in 1955, he correctly stated that the world has already reached a stage of urbanization in which there is no return in urbanization, and his prediction is quite well. Right? We know that after that, the urbanization happened. Increase very fast in the developing countries as well. And although the urbanization level in Asia and Africa is still low, but it increased very faster. And the projection of future climate urbanization shows that the trend will continue. The increase of urbanization will continue even among the countries in the high income group. And so when we look at the impacts of urbanization on carbon emission, there were large increase in the awareness of the importance of urbanization in climate change. And there is a survey among the experts of climate change and policy analysts, and about 500 experts get involved in this survey. And those experts were asked what are the most important factors that contribute to climate change for both mitigation and adaptation and challenges. Urbanization was among the top of the list that considered as important for both mitigation and adaptation. In the new climate change scenario, the shared socioeconomic pathway, for the first time, urbanization was considered as one of the core elements of future social development pathway, along with population growth and education and GDP economic growth. And this chart shows the projected changes for the future, for future world. And the projections was made for every country of the world, right? This chart shows the aggregate level for the whole world, and relative to the level of 1950, urbanization trend is aligned in purple. And it shows the increase of the urbanization level for under each of the scenario. However, urbanization is not used in, it has been used in a lot of adaptation analysis. Look at the population distribution across rural urban, and particularly the spatial distribution of the urban-rural population along the coastal area, for instance, low elevation ecological zones, and in the semi and arid areas. That's for adaptation, but for mitigation, it's not included yet in the GDP growth projections, for instance. Has been started to, the modelers started to look at the impacts of urbanization on carbon emission. And this kind of limited analysis in the impacts of urbanization in emission was largely caused by the limited understanding of the interactions of urbanization with economic growth and other factors. And when we look at the urbanization impacts on emission under the PDE framework, we look at mainly three things. First, urbanization can affect the demographic system and affect the population dynamics, and it can interact with the economic system and make a change to economic growth rate, and it also change the consumption and production patterns. So literature, one of the literature review to look at the main factors that contribute to the shared socioeconomic pathway, right? Population, education, economic growth, and urbanization, and to look at the interactions between them, the relationship between them, and based on the literature. So we put them into this diagram. The thickness of the line shows the amount of publications in the literature, and the solid line indicate the high agreement among the publications. The dashed line shows a medium agreement, and the dotted line shows a low agreement. So for instance, there are median amount of publications look at the impacts of economy on urbanization, and the agreement is high and indicate that economic growth will lead to urbanization. High urbanization is a positive correlation. And there are even large number of the papers look at the impact of urbanization on the economy. But the agreement among the publications is low because it's a dotted line. And also the relationship is not very clear. It changes in different stages of economic development and urbanization stages. A lot of example, literature look at the impacts of urbanization on population. So the publication is quite a lot. There are a large amount of publications indicate a high agreement on the negative correlation. And reversely, and there are a median amount of publications look at the impacts of population on urbanization. And the agreement is medium and indicate a positive correlation. So for instance, meta-analysis look at the impacts of urbanization on fertility and mortality in Global South, and shows this graph shows the fertility differences among rural urban in different developing regions. And it all shows if you look at the solid line, the red line shows the fertility level of the rural residents are almost always higher than the urban residents, which is in blue, the solid line. More importantly, and it also shows that the migrants moving from rural to urban shows a relatively low fertility rate, right? Not lower than the rural residents, but also lower than the migrants moving from urban to rural. So that's something like very interesting, right? Very important for look at the impact of urbanization on fertility on population. And so the mortality also differ among the rural urban area. Even in one of the most developed country in the US, you see the gradients of the mortality life expectancy among the regions in different levels of urbanity. And this is not only for the overall population, but also differ, and the gradients happen for both the rural female and the male population. So urbanization matters to population growth. And this graph shows the impacts of urbanization, the relationship between urbanization and economic also, and carbon emission. On your left, it shows for the period of 1950 to 1910, the economic growth and urbanization levels in different part of different regions of the world. And the black line, I hope this will work. Yes. Yeah, the black line, that shows the whole world, right? And the urbanization, the economic growth, the per capita GDP increased, while at the same time the urbanization level increased from around 20% to go beyond 50%. And you see almost for all the regions, GDP growth positively correlated with increase in urbanization. And particularly, I want to indicate that Latin America experienced a very rapid urbanization. Although the increase in economic growth is moderate. And I want to draw your attention to the region in sub-Saharan Africa. For the whole period, the urbanization, although Africans' urbanization level is the lowest still, but it increased during this period, although its economic growth basically stagnated. So there is large variations among regions to look at the relationship between GDP growth and urbanization. And the graph on the right shows the urbanization and the carbon dioxide emission. And you see the large variation between across regions. Basically, the right lines demonstrate shows the relationship among the developing countries, and the blue lines shows the pathway among the industrialized countries. And basically, the urbanization level increase in developing countries, right? Particularly among the Latin America, right? Urbanization level could as high as in the industrialized countries, but its per capita carbon emissions substantially lower than the industrialized countries. The only things like I want to talk about is the large increase in the per capita carbon emission in East Asia, that's mainly driven by economic growth in China. And this is, the data is a bit older. But in fact, recently, the per capita carbon emission in China is now reached as high as in Western Europe. And so the big increase of the carbon emission, per capita carbon emission in China is largely driven by the rapid economic growth. Urbanization contributed to that trend. This graph shows the labor income. Yeah, we can use as an indication of labor productivity. Yeah, you see large differences between rural and urban among the households by age, according to the age of the household head. And if you move a larger proportion of the people from rural to urban, that means the increase of the labor productivity and driven economic growth. And the increase, the difference between rural urban not only happened in the income, but also happened in the consumption patterns. If you look at the differences between urban and the rural, the right line, the right bar shows the differences in expenditure. And the urban households expenditure is significantly higher than in the rural. This also happened in many other countries, including India, and many other developing countries, and also in one of the industrialized countries with high income. And in the industrialized countries, the difference between rural and urban is supposed to be small, but you still can see some differences between rural and urban in that country. And not only the level of expenditure, but also the structure, the expenditure, the consumption structure also differ between the rural urban and changing along the, with the economic growth. And if you look at the impacts of urbanization and other demographic factors, and for instance, look at the consumption patterns across households by rural urban and also by education levels. And this graph shows that you see the gradients, right? among the households by education from illiteracy to tertiary education. You see the gradients for both rural and urban areas. But the differences between rural and urban is more significant, right? Than even in Chinese case, even higher than education. And if you put the countries along the urbanization level, then you see the changes in the household expenditure structure. So recently, a large number of the papers engaged in the impacts of population changes and carbon emission. And we review the literature and look at how econometric models to deal with, to understand the interrelationship. And largely, they use the STIRPAT model, which is a I would say improved STIRPAT model. It look at release the assumption that 1% of increase in population or economic growth lead to 1% of carbon emission. And it look at the elasticity of the changes of each of the components, demographic factors on emission. It shows that in general, population growth, increase in population size will lead to increase in emission almost positively from all the analysis. And we look at, all the papers also look at the impacts of urbanization on the emission and use the STIRPAT model and also all indicate a positive relation between the two. And the correlation, the contribution of urbanization to emission is as strong as the total population size, and sometimes in some cases even stronger than the population growth, right? For instance, this is the study and that study, right? The urbanization impacts are higher than the overall population growth. And they also look at the relationship among countries in different income groups. And all shows the positive relation. And even some of the studies shows that the high income countries are supposed to reach a very high urbanization level, but their contribution of urbanization to emission could be as large or even larger than in the low-income countries. So that's something like very interesting and need more study. And this analysis, although it's a stochastic analysis, release that assumption of a one-to-one kind of relations, but it didn't look at the interactions between the components of the changes, say population or urbanization, how population urbanization may affect economic growth then lead to changes in emission. Those models will not be able to accommodate that kind of relation. And so we use one of the model, CG model, that can accommodate to look at the interactions between all the components. This is the model then to look at the changes in, say, demography, right? Indicated by the household that interact with the producers and that lead to economic growth and emission. So that's the typical model, and then you are able to look at the interactions. This is the study and look at the impacts of population changes using the UN high, medium, and low scenario. This is the kind of older analysis published in PNAS in 2010 already, and use the PAT model and that project the future changes of the carbon emission under different scenarios, population scenarios. You see the significant differences between the high and the medium population growth, right? By the middle of the century, the differences in carbon emission can lead to 1.7 gigaton per year between the high and medium population. By the end of the year, the differences becomes larger, 7 gigaton. And we also look at the net impacts of urbanization and other aging and other demographic factors on structure changes in carbon emission. While aging leads to lower emission, and urbanization always leads to increase higher. The net impacts of urbanization is positive on carbon emission, and the contribution of urbanization on carbon emission is higher in developing world, particularly China and India, and particularly in China. And the impacts in the industrialized countries is relatively small. This analysis give us some good indication of the impacts of population and urbanization on emission. But this analysis doesn't account for the uncertainty in the urbanization. And we know that urbanization depends on which region you're talking about, right? In the past, there is a large differences, large uncertainties. Sometimes could urbanize faster, sometimes could slow down. And we need to accommodate to also understand how the uncertainty may contribute to the emission, urbanization. Uncertainty in urbanization may contribute to changes in emission. One of analysis is to look at the impact of urbanization on carbon emission in China and India, and consider different urbanization scenarios, the faster or central or slow scenario. And this graph shows that under the faster scenario, right, India and China's urbanization level will be converged to a very high level, about 90%. But the differences could also keep as low as, the differences can keep as big as today, right? By the end of the century. And we also, this graph also shows that the uncertainty in urbanization is high in India than in China. That makes sense, right? China is more urbanized, so the room for the uncertainty is also small. Then we use the PDE model and to look at the impacts of urbanization, different urbanization scenario on the economic growth. It shows that under all the scenarios, the economic growth will happen in both India and China, and the increase in China is faster than in India. And so far, this is the case, right? But depends, on the future path of economic growth in the two countries. India now, the GDP growth is more than 13%, and then China's GDP growth declined to this year is only 3%. So, but this graph shows the differences, right, among the under different urbanization scenarios, and this shows that the variation is not very big. And then, but the impacts of urbanization, economic growth, and on consumption can lead to substantial carbon emission differences, particularly in China, right? And so it shows that in the next 2 or 3 decades, the carbon emission in China will increase very fast, but after the middle of the century, and it can decline slightly. And the variation among the urbanization scenarios, the differences is larger than in India. So this is very interesting. And so one thing we look at how urbanization contribute to, good enough. How urbanization contributed to carbon emission differences. And one thing we look at whether this is driven by the consumption patterns, the differences between rural and urban, right? Or this is driven by both consumption and the economic growth. And so if you only account for the consumption patterns, which lead to the dashed line, right, is slightly lower than the central than the original results. When you consider both consumption pattern and the effects on economic growth, then that will be exactly the same as the curve, right? And actually, the case only consider the consumption pattern under the fast scenario, and is almost the same as the central urbanization scenario. So that's something like that. You can think about the magnitude of the differences. Consider either consumption pattern or the impacts on both consumption and economic growth. And so this, those kind of analysis improve our understanding on the impacts of urbanization. However, we are aware of the large variation in the impacts of urbanization on economic growth, on energy consumption. This the graph shows all a lot of cities in different parts of the world, and the blue dots are the cities from the industrialized countries, and the red one are the cities from the developing world, and the horizontal line shows the national per capita GDP. So it shows that the cities per capita energy use in industrialized countries is almost always higher than the cities in the developing world. And more importantly, this graph also shows that in the industrialized countries, the cities, the per capita energy consumption of the city residents is lower than the national average. Yeah, if this is a line, right? The diagonal line shows if the per capita energy consumption is exactly the same between the urban residents and the national average, right? Below that that line shows the city residents per capita energy consumption is lower than the national average. And this graph shows that in most of the cities in industrialized countries, it is lower than the national average. Means the economy of scale achieved in the urban area, right? But in many of the industrialized cities, and that's not clear. And actually, many places, the per capita energy consumption of the city residents is higher than the national average. And so that shows some differences. This is the kind of pattern. We can also look at the energy intensity, and due to the time differences, I skipped that one. And even within the country, right? We look at all the cities in China, for instance. Look at their per capita carbon emission among the residents, and by the city features. And the graph shows that the income, right? That's the green line. The temperature, the winter temperature, that's the gray line, and also the red line, the industrial structure of the city matters to the per capita carbon emission. But it also shows that the population density of the city demonstrated a negative correlation with per capita emission. So city features also matter to the carbon emission. So we need a further study. And also even within the city, right, we also you should consider the differences among the city residents. This graph shows the income levels per capita income of the residents of rural-urban residents among the Indian population, the households. And it shows that the urban residents without access to electricity has a very low income level. That level is not only lower than the urban residents, right, but also lower than the rural residents with access to electricity, and even lower, slightly lower than the remote area in the rural area, right? So that means that there is a large inequality among the urban residents inside the urban area. So what we need for future studies, and we need to do more empirical analysis and to look at the interactions between urbanization, economic growth, and other socioeconomic, socio-demographic factors. And the relationship of the urbanization and with the emission should be looked at a different stage of development, urbanization, and look at the urbanization growth rate, and also consider the urban form, right? Whether it's urban sprawl or compact city, urban form. And we also need to extend our analysis beyond this urban-rural dichotomy. We need to consider the differences even among the cities, right? Across the urban spectrum, even either this is a large city or medium city or small towns. And so we also need to acknowledge the urban inequality and address the climate and environmental justice issues. With that, I stop here. Thank you for your attention.